And hello there. If you're watching this video, this means that we're ready to start talking about combining like terms. Now, before we talk about combining the like terms, let's just talk about what a term is in general. Now, a term is what we can refer to as a little piece of algebra or a little piece of math to be acted upon. So a term could be 3. That would just be a number. A term could be a variable. We could say x. Or a term could even be 3x. It's referring to how many x's that we have. So when we think about terms, they could have multiple parts from it. From a general standpoint, I could represent it as x to the n, where x would represent the variable. A is what we call the coefficient, and n is what we call the power. So what will determine if terms are alike is if they are made out of the same variable and the same power. So for instance, 2x and 3x, these would be like terms because they have the same variable and they both have a power of 1. But something like 2x and x squared would not be like terms because the x squared has a higher power than the regular 2x does. Something that you might not have thought of is that we consider 3 and 5 to be like terms. So even no variable is the same variableness, if you want to put it that way. So when we combine like terms, what we're really doing is we're just collecting them all together. We're looking to see if they're positive or negative, and we're just keeping track of how many we have. And it doesn't really matter where they are, but we're using the symbols to help us count them all together. So first what we're going to take a look at is what combining like terms looks like in an expression. Now remember, an expression is just a bunch of numbers and operations, but there is no equal sign. That's what makes it an expression. So here, everything's fair game. I can kind of look at it and go one by one. Let's say I want to collect all of my variables first. So I found 2x. This is actually subtracting 5x. Now the key when you're combining like terms is to always look in front of it to tell you how it's going to react. So this 2x right here, that's actually positive. We don't see anything in front of the 2, which indicates that just default we assume a number is positive. So I have 2x's, I take away 5x's, I add 3 more x's, and that's it. So here it's actually 0, and it just goes away. So it is gone. Now if I look at my other numbers, let's see how they combine. We have a plus 8 plus 1, which makes 9, and 9 minus 6 would be 3. So overall, when it's fully simplified and all of my like terms have been combined, I just literally have 3. Our x's canceled out. Let's take a look down here to see how this one's just a little bit different. So if I look at this expression, that is something different. We have x's, and we also have y's. So here's some y's, and here's some more y's. These are obviously not going to combine. An x is not a y. So when I'm counting them together, I would have, let's see, 12y's minus 6y's, that would be 6y's. And if I count up my x's, 20x's plus 2x's would be 22x's. And oh, we have some regular numbers here. We have minus 10 and then minus 16 again, which is going to be more negative, minus 26. So again, when we're thinking about combining like terms, we're looking for all of the similar terms that have the same variable and the same power. And we're just adding and subtracting them together to see what they will naturally combine to. Now, in an equation, we often want to see if we can combine like terms from the beginning. The thing that makes it different is we can only combine like terms on the same side of an equal sign. If we want to move something to another side of an equal sign, we call that an inverse operation. So just to be clear, when we're combining, we're just looking at one side of the equal sign and not even worrying about the other. So right here, when I look at the left side of this equal sign, I notice I have a like term here and a like term here. 5x doesn't have anyone to mess with, but 7 minus 8 would be negative 1. So I see minus 1. Over here on the right side now, I see that the x's are actually my like term. I have more than one x. So 3x's plus 4x's would make 7x's. And the minus 18 didn't have anyone to combine with, so it stays minus 18. So this can be a rather confusing notion. So when we're thinking about combining like terms, we're only allowed to work with one side of the equal sign. And when it came to the expression, well, we could just do everything here because there was no equal sign. Everything was the same side. Let's disable this. All right, fun little fact there. What you just saw in action was my screen darkener, I guess, because the blue light that comes out of the computer screen will actually keep you up later. Your eyes are actually trying to keep you awake, I guess, if they're getting blue light. But the red light, the orange light, it simulates a sunset. So if your computer is giving more orange tones, it actually helps you go to sleep. So I hope you guys actually find a program like that. But let's continue with this. That was a distraction. Okay, let's look at some like terms on the left. So I see that there's 4x's, and then we take away 20x's. That would be minus 16x's. This 18 didn't have anyone to combine with, so it still stays plus 18. On the right side, I notice that there's two different types of like terms. I have my x's again, so this would be 9x's minus 14, so minus 5x's. And I also have regular constants, numbers. So if I had 32 minus 12, that would be 20. So just to wrap this all up very quickly, when we're combining like terms, we're trying to figure out which terms have the same variable and have the same power. The number in front, or the number itself, is just keeping track of how many there are, the coefficient. If it is an expression, combine everything together that you can. Sometimes they'll actually disappear, but a lot of the times everything will remain. And if you're dealing with an equal sign, you can only combine one side of the equal sign. So only the left can be combined with the left, and only the right can be combined with the right. If we actually wanted to solve this, then we need to start talking about inverse operations. So first, complete this assignment on combining like terms, and then we'll move on to inverse operations, what we'll need to actually help us solve for x.